exponential functions, some factoring, stuff like that, okay? So it's going to have some of this logarithm stuff, and it's going to have some exponentials, it's going to have a bit of factoring, maybe some other stuff, okay? So try and stay on top of, don't let everything from the previous units fall out of your brain yet, okay? You're going to need to hang on to it. Okay, so we've got the spell work. So we have this function that Freddie has taken the liberty of graphing and finding transformations, domain, range, and the asymptote. And I need you all to take a look at his work. And if you see a mistake, take note of it in your book and then correct the mistake. All right? Using a logarithm, so think about a, h, and k, what those do. Think about what our domain is. Think about what our range is. Think about what our asymptote is. Okay, so let's give you guys a couple minutes. Work on it. See where he may or may not have made mistakes. All right, let's start thinking about this. So Freddie's got this function, and he's written two transformations up here. Do we see a mistake in his transformations? Yes. Which one's wrong? Left 2. That's not right, is it? Nope. What should it be instead? Right 3. Very good. And that's because we have x minus 3 up here. Minus 3. That means h is positive 3. We move right 3. Okay? Very good. How about the domain and range? What do we think about that? So when we're using logarithms, which is our domain or our range all real numbers? Range. Yeah. So range should be all real numbers, not the domain. How about our domain? What is our domain in a logarithmic function? It's h to infinity, right? So Freddie uses k for the range, to limit his range, but with a logarithm we use our h to limit our domain. So we just talked about how our h is 3. So it should be 3 to infinity, okay? And then a vertical asymptote. So he says y equals negative 2. Right. It's x equals h, not y equals, well, his k is even wrong, but that's not the point. It's x equals, not y equals, for a vertical asymptote, right? It's for a logarithm, it's x equals h, so it's not y equals negative 2, it's x equals 3. And then, I'm not going to use a lot of detail to correct this graph, but instead of negative 2, we're going to have our asymptote over here at 3, positive 3, and then the graph's going to look something like that, roughly, something like that. Okay. Nice. We feel good about transformations. We feel good about domain and range. This is stuff we're really hammering down. Graphic is important. It's a lot of points on a test. So there we go. Cool. Let's move forward then. So yesterday we talked about evaluating logarithms, we talked about change of base. We talked about how if the base and the number are the same, it equals 1. And then if we have a base and the number is 1, then it equals 0. So we got those 3 down. We practiced with those a little bit. And today we are going to do something a little different. Still working with logarithms, but we're going to think about it more algebraically than with a calculator. Okay? So turn to page 125, please. So this part up here is some quick review. Exponential form, b to the x equals a. Log of b, log base b of a equals x. We should know this by now. Like that's the relationship between an exponential function, and a logarithm. Okay. And then quick review before I let you guys copy the rest of this down. Log with a base of 1. What does that equal? That's from yesterday. Log with a base of 1. Let's see if you remember. 0. And then log with a base of the same number of the base. That one's 1. All right? So just that's stuff that we're going to want to know automatically. So we're just emphasizing it. And you can always check back in your notes from yesterday to see how we got those. So we got that. Take a couple minutes, copy these down. We're going to talk about them soon. Okay?
This is the study guide. It's 6 pages. So we probably want to cut it. So you can kind of look at it. Like, see, this has that one question. Base 5 is kind of big. Maybe we'll change that.
Yeah.
Because it's kind of, they can only,
Yeah,
you can't even put, yeah. So we'll probably change base. But yeah, you go ahead and look at it.
Yeah, I'll look at it.
If it's not, like, if this isn't there, take it off.
Yeah.
Oh, this question is there. That's cute. All right. So that's that.
Yeah.
Couple more tests back. You're busy.
Always something
You're
to work
becoming
on.
a regular teacher. Full plate. Wow.
I might have used my middle name as well. It's Edwards.
Like that?
Yep.
Field. Like that?
Yeah.
Okay.
So I applied for it on Elvis.
Okay.
Yeah.
This is one of the assistant principals.
Yeah.
Mr. Sidella. We have like 6 different ones. So.
Yeah, and I know who to email about getting the paperwork for payment and stuff.
You did? Okay.
Yeah, so I can email them. It's
Okay.
Mothry or something like that.
Okay. So I'm sending. He just want to know your full name.
Yeah.
He's gonna check on it and then he'll let us know.
Okay, cool. And I should have a background. I have a background check and
Yeah.
access and all that kind of stuff. So.
Might as well get some money.
Yeah, I
Do it
should have
real-
done it earlier, but I was just like,
No, that's fine.
you're such a workhorse. I figured you were never gonna miss it.
Did I not teach you anything? I'm feeling.
All right, we've got these properties in. Hopefully, if not yet, keep writing. I'm going to start talking about them a little bit, and then we're going to see what we're going to use these for soon. You can probably look down the page and see where we're going with this. But so we got one that's called the product property. Okay, so this is when we have a log. B is any number. It's just a base. It's just no base. It's going to be any of these. So we have a logarithm, and we have 2 numbers that are multiplied together inside of our logarithm. Okay, we have a product. Hence product property, okay? So what we can do with our logarithms is we can expand our product so that it's the log of the first factor plus the log of the second factor, okay? It's multiplication. You can expand it out into addition. All right, so quotient property. This time we have the logarithm of a fraction. And fraction is the opposite of multiplication, so it would make sense that when we expand it, we do the opposite of addition, which is subtraction. So we can expand this to the logarithm of p, which is everything on the top, everything on the numerator of our fraction, minus the logarithm of q, which is everything on the bottom, everything on the denominator of our fraction. Okay? And then last is the power property. This is if we have logarithm of any number to a power, to an exponent. And what we can do with this is we can pull this exponent out front, multiply it against our log of this number of our that has our exponent in it. Okay? So you've got these properties. Make sure you have these down. These are important. You're going to want to know these. Okay? And then next we're going to talk about one thing we can do with logarithms. When we have variables in our logarithms, we can expand them. We can make them more simple, in more terms, but more simple. Okay? And so we're going to talk about what steps we need to take in order to do that. We got a set order of steps that we do for this, okay? So here are our steps to expand. All right, so this is what I want you to write into your notes, where it says steps to expand, 1, 2, 3. These are our steps. So take a minute, copy those in, and then we'll talk about them a little bit, okay?
I'll kind of look at it too, like the ones I think.
Yeah.
Is this the midterm?
Yeah, I was hiding it.
Oh yeah, that's smart. Just don't highlight.
I mean, if you can think of, you didn't seem to like this question very much, so.
I know.
Also, there's nothing.
There's no system question?
Well, which is a little surprising. But
That's what we're gonna take off. We're gonna let this whole page off.
yeah. Yeah, I don't think we should ever use anything that's not.
Yeah, I just kind of did.
All right, getting our steps in. Give you guys 30 more seconds. Okay? Okay, so we have our steps. These are our steps that we take to expand a logarithm. And it's in this order because this is the order we need to go in, okay? So first step, we look at our logarithm and we see if there's a fraction. If there's a fraction, we separate the fraction into subtraction, okay? And for each of these steps, we're implementing one of our properties that we just wrote down, okay? So which property do you think we use for step 1? Quotient property, yes. So the first step, we use a quotient property. We look for a fraction, and if we see it, we use the quotient property to expand it into subtraction, okay? So you can, I don't know if it's necessary, but if you want, take a note of which property applies to which step, if that might help you, feel free to. But this is just extra information. Okay, second step. After we've separated our quotient into subtraction, we look for where there's multiplication. Okay? So anywhere where there's multiplication, we expand each of those out into addition. All right? So which property are we using here? Product property. Yep. So product property. So step 2. We look for multiplication, we use the product property. Okay? And then last, we look at each of our logarithms. We look for ones that have an exponent, that are a number to the power of something. Okay? and we move the exponent to the front of that logarithm. So which property are we using here? Power property. Okay, so first step, one more time, first step, we look for a fraction, we find one, we use the quotient property, make it subtraction. Second, we look for everywhere there's multiplication, we use the product property, we make it addition. Third, we look for any exponents, we use the power property to move our exponent to the front of our logarithm, okay? Make sure everyone's got this down. You guys are gonna need this. This is important. Throwing a lot of words at you, a lot of abstract stuff. So let's look at it in a concrete example, all right? So here we go. Number 1, log of 5y over x to the 4th. All right, so what's our first step? What do we look for first? Fraction. Yep, we're looking for a division, a fraction. There we go, we got 5y over x to the 4th. That looks like a fraction to me. So we're going to use our quotient property, and that's going to look like this. So we just do log of 5y, everything in the numerator, minus the log of x to the 4th, everything in the denominator, okay? So just like the quotient rule says, quotient property, says log of a fraction. We take log of the numerator minus log of the denominator, okay? First step, check, done. Second step, we're looking for multiplication. So look at this first one, this log of 5y. We've got a 5 and a y, that's 5 times y. There's some multiplication in here. Second one, x to the 4th, no multiplication. It's just one piece, just an x to the 4th, so there's nothing to do with that one, okay? So I have a 5 times y, my first logarithm. Use the product property. We're going to change that to addition, okay? That looks like this. Log of 5 plus log of 1. Am I writing big enough for people in the back? Is that okay? Okay, just checking. Notice I was writing a little small. I'm going to check. All right. And then this piece that we didn't do anything to, that's going to stay the same for now. So still minus log of x to the 4th. Okay? So we have found some multiplication. 5 times y, log of 5 plus log of y. So that, okay? Last step, we look for one that has an exponent. Which one of these has the exponent? X to the 4th, right? There's an x to the 4th. There's our exponent, product property. We can pull that to the front, okay? Everything else stays the same. So log 5 plus log y minus 5 log of x. The 5, oh, it's a 4. Whoops. 4. Not trying to confuse you guys. 4 log of x. I got the 4, not the 5. I got the 4 from the exponent, right? Because the exponent goes out to the front. Okay? It's just, it takes some deliberate paying attention to the steps, just being careful of the details, but it's pretty straightforward. Okay? Does anyone have any questions about those steps we took to expand this expression? The y? Where is it?
Yeah, I thought you put it.
Well, it's in the, it's right here. See it? It's at the top part of the fraction. Okay? Yeah. Okay. Let's do number 2 together. All right? So number 2, we have a log base 3 with 4x squared y to the 8th z. Okay? So first thing we look for a quotient, we look for a fraction. Do we see any division going on in this one? No, there's no fraction, okay? So if one of our steps doesn't apply, we skip it, we go down to the next step, all right? So step 1 doesn't apply, we go to step 2, all right? So step 2, we look for some multiplication. There's a lot of multiplication here, right? So this part you can do if it helps, right? But you don't need to. I'm just going to take a note that it's 4 times x squared times y to the 8 times z. Okay? So I'm just breaking down this piece into all the pieces that are multiplied together. So I know what to expand. All right?
What do you do with log?
We'll use it. This is just me writing this part out. So I'm identifying all the factors that I'm separating out. Okay? So we're going to write that as log 3 of 4 plus log 3 x squared plus log 3 of y to the 8th plus log 3 of z. Okay. So we identified every factor of that multiplication going on in our logarithm. We separated each one by addition. Each one. You got to do each one. Can't keep any of them together. Everything's got to be separated. Yes?
Is that a G?
Probably. Yeah. Yeah. It's all those are log. Yeah. Okay. So we've separated multiplication. Next step, we use the power property. Okay. So we look for ones with exponents. See that that's going to be, we got an x squared here, we got a y to the 8th here. So we pull those out to the front. Keep everything else the same. So this is log 3 of 4 plus 2 log 3 of x plus 8 log 3 of y plus log 3 of z. Okay. Any questions? I love questions.
So you just put the numbers
For the exponents?
Mm-hmm.
Yeah, you just pull the exponent out to the front. Yep. Okay. If everyone feels okay about the steps we're taking, I want you guys to try number 3 by yourselves. What? That's scary? Okay. All right. Try your hand at number 3. Take care of the steps. Take care of what's in the natural log. Okay? If you have any questions, I'll be around to help, okay? Oh, you want to go back? Yeah, I got you. Yeah, sorry, everyone. I'll keep these up. Once you get this copied in, start trying number 3.
always put the L in. So every time you expand it, you have to keep that L in with it. Sit up straight so your brain not go sleep. Ready? Okay. Okay. That's perfect. Good. So you just gotta move this too. Yeah. That's good. So remember, how this W is squared. Oh, I see what you mean. You moved it, you moved it too fast. So that's the last thing you did. The last thing you do is move the exponent. So you want to explain it to ln 3 plus ln w plus ln x squared minus ln y to the third. But the last step is to move the exponent. This is log 5. So log base 5, and then you put this higher. Minus log base 5. Log base 5. You gotta put the log in. Okay, now you look at things that are being multiplied and subtracted by addition. So you see how these are being multiplied, so it's gonna be log base 5. 9 plus log base 5. So these two are, we're just separating these two with the plus. So
I'm gonna go, and I'm gonna go, we're gonna do this, because this, if you do subtraction, this minus this one.
Okay. So then these are being multiplied, so these go plus
I'll go over to the
log base 5. Okay. And then the last thing you want to do is move your exponent. So everything that has an exponent. So this doesn't have an exponent. So this 5 is going to be this 5. This 5 is first separate the subtraction sign, and you look for addition. Imagine what that is. Yeah. And then the last thing you gotta do, so this doesn't have an exponent, so it's just ln w. This does have an exponent, so you gotta move it to the front. So that 2 moves to the front. 2 ln x. This 2. If there's an exponent, you gotta move this exponent. And this is w to the 4th. So now, everything that's being multiplied, you're gonna break it apart with addition. So it'll be ln 3 plus ln w plus ln x squared minus ln y to the 4th. Now anything with an exponent moves to the front, so you see how there's 2 exponents. This 2 here, this 4 is here. So it becomes ln 3 plus ln w. So that's why the first thing you do is look for a fraction separated with subtraction. Second thing, look for things that are being multiplied. And the last thing you do is try to start there.
Very close.
Yep.
I'm gonna go.
That's it.
Then, all right, everyone. Reel it back in, reel it back in. Back in, back up front. All right, I'm gonna go over number 3 real quick, and then I'm gonna walk us through number 4 because there's a little trick that I want us. There's a detail that I want us to make note of that we're gonna need. Okay. So number 3 is backwards. Okay. Number 3, we saw the fraction. I saw a lot of people work on number 3 while I was going around. So nice work. Way to give you your best shot, everybody. Okay. So we saw an ln of 3wx squared minus ln of y to the 4th. Yes? And then you can take a note that this 3wx squared is 3 times w times x squared. Make sure we're separating each piece, each factor of this part that's multiplied inside of our logarithm. Okay? So we separate each of those. Ln of 3 plus ln of w plus ln of x squared. There's no multiplication with our y to the 4th, so it's just ln of y to the 4th. And then last thing we do, this one has exponents, this one has exponents. Everything else stays the same. Plus, we bring the 2 out front, and we bring the 4. Okay? So check your work on number 3 with what we have up front. If you made a mistake, try and look and see what you messed up. That's okay. We learn from mistakes. If you got it, nice work. Now I'm going to go over number 4. Okay? We got time. We've got time. All right. So number 4. It's the same thing, right? So we have the fraction with a numerator, denominator. Yeah, we got this too. All right, so we got log base 5 of 9b to the 5th minus log base 5 of y squared w to the 4th. Okay. Now we've got some multiplication in both of these. This is 9 times b to the 5th. Over here we've got a y squared times w to the 4th. So this piece over here is log base 5 of 9 plus log base 5 of b to the 5th. Now here's the detail that I want us to take a note of on number 4. So we have minus log of y squared times w to the 4th. And we're expanding that, but we still are subtracting this whole logarithm, okay? So we do subtraction. We need parentheses. You need parentheses, okay? We need parentheses, and then we expand, okay? Log to the 5th, log to the 5th, log 5 y squared plus log 5 up to the 5th, w to the 4th, and close those parentheses. Okay? And we need parentheses because we're subtracting this whole logarithm. This is still equivalent to this. So the whole thing needs to be subtracted. Okay? If you want, you can distribute the negative. If that doesn't mean anything to you, don't worry about it, okay? Either way, it works. And from here, it's pretty straightforward. We look for these exponents. There's one, there's one, there's another one, okay? So this first one stays the same. Pull the 5. And minus, I'm going to keep the parentheses, 2 log 5 y plus 4 log 5, that's a 5, I swear, 5 W. Okay. So just the key from number 4 is, remember, if you are expanding a piece that you're subtracting, you got to make parentheses. Okay? That's important. All right, we've got 7-8 minutes. You can check on your homework. You can look over these notes. You can ask questions. If you got questions, please, I'll be around to ask.